Hello, this is kind of a continuation of the cheap-ass quadcopter build series. The actual build itself is all done at this point, of course, but in the last video well, I did anyway, I don't know about you, but I have now a transmitter that has 8 channels, and so there's the ordinary 4 channels for flying the quadcopter itself, and then we have 2 analog channels and 2 binary switches there. So since we have a microcontroller on board here as well as our flight controller, I thought it'd be a good idea to make a video where we look at something interesting that we can do with these extra controls that we have. And what I'm going to do is put some lights on the quadcopter, and I may even actually look at making a buzzer as well. So if you've had any experience with Arduino, you're probably aware that making an LED light up is pretty much the first thing that you ever do. It's like Arduino 101. But what we're going to do here is use some rather more high-powered LEDs, but we still want to control them with the Arduino, so we have to interface the high power of the LEDs and the LiPo battery that we're going to be powering them with the low power signals of the Arduino. And for this you're going to need obviously some LEDs, and you're also going to need probably a little bit of wire to connect things up, and you'll also need at least one power transistor. Now, none of the stuff that I've got in this video comes from Banggood, for a change. I actually got all this stuff locally, but the LEDs that I've got, I'll just have a look at them here. Just put all this stuff away. So I've got a few LEDs. This one here is a 30cm strip with 12 LEDs on there. I actually got this to stick above my desk here and make some lighting for my videos, and for when I'm working on stuff, of course. These ones here are basically the same. They're just a 3 LED section of that same kind of stuff. These ones are red, these ones are just white, and you can get these on eBay. You can get, I think, like 5-meter long strips of this, and you can cut it into sections to make it whatever length you need. And these are quite easy to power. They're made to be powered from 12 volts, and you'll find that if you have 12 volts available, you can just power them directly from your the main battery of your LiPo. It's red. What have we got? Green. That way. Okay, so that's supposed to be green. Doesn't really look very green in the video. But if that's all you want to do, then you don't really need any of this Arduino or the controls or anything like that. So you can just connect these up directly to your battery like that, so that when you plug your battery in, the lights come on and that's it. This one here is pretty much the same. It just requires 12 volts as well. So it lights up like that. Pretty simple. I'm not going to use this one. I'm just going to put that away, but I thought you might like to see it anyway. I'm going to use these. I have 2 red and 2 green, and they're going to go on the corners of my quadcopter, and they're just going to sort of be brutally bent around like this so that they wrap around, so that I can see one of each of these lights from each direction. So that's how that's going to work. And I have another set of LEDs here. These are 3-watt LEDs. These also come in various colors. I have some more red and green ones here, but the one I'm going to put on is just going to be a white LED, and I'll put that right on the bottom so I can sort of see the ground underneath the quadcopter as I'm coming down to land. Now, these LEDs are a little bit different. You can't just slap them straight onto your battery. If you've seen any of Julian Eilert's videos, you've probably seen lots of these, 30 or something in one video, I think. But they're going to require some sort of a driver to make sure that they don't get too much current. And like I say, none of this stuff comes from Banggood, so I can't really give you links or anything. But I happened to get hold of these little driver things. If you're in Tokyo, they come from Akizuki Denshi, which actually do mail orders online anyway, so you can get them over the net, and they're pretty cheap, just over $1 each. And these connect up like this, so you just connect that driver up to the positive and minus on your LED. Come on. And then over here, it's actually able to take AC input on the input side, so you can just reverse those battery connections there. It doesn't really matter. And let's have a quick look at this. We won't be able to see too much in the video probably, because this is a really beastly bright LED, but hopefully we can see something. Oops. Okay, so it's green, as you can see, hopefully. It maxes out the camera's white setting there, doesn't it? Anyway, these also get a bit warm, which is one thing that you might want to consider. So I'm not sure if I want to stick this directly to my balsa wood quadcopter frame. I might put a little piece of aluminium underneath it as well, just to give it a little bit of heat sinking. So anyway, all these here, I'm just going to look at these, but one thing that's important about these is they all have some kind of current limiter in them. As you can see there, and there are some small resistors inside this one, and this one, obviously the driver itself limits the current. Now I just want to go back to Arduino 101 for a minute, because I want to look at how we're going to interface those high power LEDs with our Arduino controller. So I have this here, which is a Arduino Uno, and there's a pretty simple setup on here. We just have a little resistor coming from ground, and that's going through an LED, and on the other side of the LED we are connected to nothing at the moment. But if I put this into the 5-volt rail, we can see that the LED lights up. And if I put this over into my pin 4, you'll see it blinks, because I'm running the blink switch, blink sketch, the Arduino 101 sketch. So obviously nobody's learning anything new from that, but I just wanted to make a point of this, because this is basically the same thing we had. We have a current limiting resistor, and then the LED, and then we have some kind of power source. And in this case, with this tiny LED, we can run everything from the Arduino itself. But let's have a look at the circuit diagram that we're going to need for making use of higher power transistors. Alright, here we go. So this setup is going to be aimed at either 2S or 3S battery setups. So the highest charge you'll be seeing hopefully is about 12.6 volts, and as the battery decreases in charge, at least for a 2S battery, you'll be going down to something like 7 volts. So that's the expected range of what we're setting up here. And obviously we have an Arduino, and this is powered of course through its raw pin, but that's not really relevant to this particular circuit, although the ground connection is relevant, so I'm just putting that in there only. And what we were just looking at before is an LED with this kind of a connection, some kind of current limiting resistor. Now obviously this looks exactly like what we just saw connected to the Arduino Uno, but I'm going to treat this little unit here of the LED and the resistor as if it were either of those other two types of LED we saw as well. So this could be a high power one as well. It basically works the same way. And what I was doing there was I was manually connecting the positive side of the LED to 5 volts or VCC. For an Arduino Pro Mini, at least the one that I have on my quadcopter, it's going to be 3.3 volts. And then when I was using the blink sketch, I had it connected to pin 4 of my Arduino like that. So that's what I was just doing. Just wanted to, like, get us grounded with what we were looking at before. Now, what we want to do is, instead of using this little wimpy power output from our Arduino VCC, which is only going to be 3 or 5 volts or so, that's not going to light those LEDs at all. Actually, it does light them a little bit, but nothing that you're going to see from a few meters away. So what we want to do is take our power from the high power rail, or directly from the battery. But that presents us with a little bit of a problem, because then there's no connection here to our Arduino to control it, or make it dim, or turn it off and on, and so on. So that's where the transistor comes in, and the transistor is going to sit right there, and then the high power current will come through here and to ground like that, and then we'll use the base pin of the transistor to switch it off and on. So that will be something like that, and this is still at the lower voltage of 3.3, but that's fine. And this is basically just a switch turning off and on, and that's how we can control high power LEDs with our Arduino. Well, I say high power LEDs, but of course it could be used the same way to power high power anything else's as well. So the transistors that I'm using, once again, I just bought these locally, so I can't really give you a useful link on Banggood or anything like that. Damn it. Okay. These were $1 for 4, so they're pretty cheap. Fairly large, as you can see. They're made to be screwed onto heat sinks. These are rated at 1 amp. So I'm going to use this for the single large LED underneath. And I might try these ones for the other 4 sets of LEDs on the corners. This is also $1, but for 2 this time. And this one's rated at 3 amps, up to 40 volts. Now, I'm not much of an expert with transistors, so to be honest, what I did was I googled Arduino power transistor, so you might want to try doing that, and there's a wealth of information there. I came across this the second link down here, and I went through this page and basically just checked that I wasn't going to do anything stupid. Came across this one. I couldn't find any of these locally, but the transistor I got seems to be a pretty good replacement, and there are a lot of transistors that are fairly good equivalents for each other, so you might want to just look around and see what you can find. Maybe you can actually find this one. So just before I get to setting everything up on my quadcopter, I'll just give you a little look at what that looks like. It's a bit hard to follow, I think, but this side is the battery rails, and then I'm bringing that directly into that LED driver there, and then that goes on to the LED as normal, except it doesn't go directly to ground from there. It has to go through the transistor. So the white one is going back to ground as far as the LED is concerned. Then on this side I have another ground, so that's the ground that we saw going into the ground from the Arduino. And then over here we have what would be the signal pin, so this would be my pin 4 of my Arduino. And as we saw from the chart, whenever there's a voltage potential of 1 volt or more across here, then the transistor will switch on and it will let the current coming through from the battery into there. So just to show you what that looks like, I always double check these now. I've learnt my lesson the hard way. Always look at them now before I plug them in. So we need to get some voltage potential across there. I could do it from my Arduino. Actually, let's try that. Okay, let's do it this way. So we have this into the ground, and then we have this one onto 5 volts there, and I'll just touch that on so you can see that the LED comes on. Now if I try connecting that to the same pin that was doing the blink sketch that I had before, pin 4, now you can see it's powering the high power LED from the Arduino signal. So this is the white LED. It's nice and bright on 3S, and the little cap had some power in it still. And you probably won't get a good comparison through the video of what a 2S would look like, but in real life it's noticeably less bright. But that's okay. Okay, so now basically I'm just going to connect all this up, and all I'm doing is putting this onto the quadcopter in a much tidier arrangement. So with these things, basically it's the same, except instead of this driver and that LED, I'm just going to stick that one across there, like that. So it's just the same. So I'm not really going to go into any details about that, but I did want to look at some strategies that we can use for turning LEDs off and on, and also for using the dials to change the brightness of them, because especially if we're going to be running our sketch on the receiver, which is using PPM to send the flight control signals to the multi-Wii board, we have to be very careful that we don't screw up the radio link. And the best way to screw up the radio link is by using a delay in the sketch. So if we have a look at the sketch that we were just looking at right here just now, this is the Arduino 101 sketch basically, and this is just using delay. So we have a pin, and we're using digital write to set it high and low, and then we're using delay to wait for 1000 milliseconds. Excuse me. And that will royally screw up our radio connection if we put that in our receiver sketch. So we don't want to do that. So what we can do is this one here. Let me just get that out of the way for a second. So on this one here I have 2 pins. I'll just look at pin 4 for now. We set that as output as usual. And then we can do something like this. I've just put this in a function. It takes the current time from milliseconds and passes that through to this function. And in this function we're keeping track of the last time we changed the pin status. So the last time we either turned it off or turned it on. And we're also keeping track of a Boolean variable that tells us whether it's on right now. And then we come in, we have 2 if statements, and the first one says if it's on now and enough time has passed since the last time we changed, in this case 500 milliseconds, then we'll turn it off. We'll record that we turned it off, and we'll also record what time we turned it off. And the other side of the if statement is basically just the same, except it's checking if it's not on, and then the same thing, except it's turning it on and recording that it's on. So this is kind of long-winded, but the point is that we're not using any delay statements to do it. So if we have a look at what this does, let me just see if I can upload this and show you at the same time. That's this one. 1, 2, 3, 4. Okay, I'll have to put this like that, I think. There. So this is the normal blink, 1 second on, 1 second off. And I'll just make this a little bit shorter for the on time so we can distinguish them. And then I'll upload this. Now you can see the off time is 1 second, but the on time is much less than a second. So we have we have the same result, but we didn't need to use any delay. And the nice thing about that is that apart from not screwing up our radio link, we can also have another kind of a delay loop running side by side. So this do blink 2 is doing exactly the same thing. It's just having a little bit shorter time, so 200 milliseconds on, 200 milliseconds off. So it's a little bit faster, and it's doing everything on pin 5. So if I just show you what that's like. So now we should be able to see that we have a pink LED and an orange LED, and they're both doing a delay, kind of a on-off thing, but they're able to run simultaneously, so you can't do this if you're using the delay function. A little bit hard to see, but that's how that works. Okay, so if you want to have LEDs just turning off and on, that's fine, that's a great way to do it. Now if you want to dim them, so if you want to use the dial to like turn the LED brightness up and down, I tried doing it like this and just setting these numbers to be like very low numbers. So you'd be like 1 millisecond on and then 2 milliseconds off or something like that. But it just doesn't work. It looks all like flickery and horrible, and yeah, it just doesn't work. So one thing you can do is you can use analog write, which will send a PWM signal to the LED, to the pin that you're writing to. And this, we have to be careful with this one. We can only use this on pins 5 and 6 because it uses timer 0, and that's how the PWM works for that timer. Now if you recall, in our receiver sketch we are using timer 1 to work with our PPM data, so we can't use anything else, like we can't use any of the other PWM pins to do this. So basically you only have 2 pins on your Arduino on the quadcopter that you can do this with. So just keep that in mind. Let me just set up an analog input dial on here. I just have this like a potentiometer that I'm going to use to set this up. Right, now hopefully we can see when I turn the dial that we're getting there we go. You can see when I turn the dial it changes the brightness of the LED. Doesn't seem to change it much once you get to about a quarter of the way up the dial though, so it's not really good like that, is it? But that's about the best we can do. So you can get this working together with the other two, and notice that we're still not using any delay in here. So let me just copy these into that other sketch. That one, put that on pin 6. Okay, so now we should be able to do both of those. I only have 2 LEDs, so I disconnected the other one. But you can see that we have one delay going off and on, and we also have our PWM going as well. So, yeah, I don't really have a whole lot more to add. I just wanted to point that out. Don't use delay. That's the moral of the story. So basically, yeah, I'm just going to put a little bit of something like that into my sketch on my receiver, and if we just have a look at the receiver sketch now, we'll see we have this struct my data, and this is what's coming in from the RF24 module. So I'm just going to use one of these byte values here to change the brightness of I think I'll use that to change the brightness of the white LED underneath the quadcopter, and I'll use one of the switches to turn the red and green lights on the corners off and on. So that's what I'm going to do with that. Now this video's gone on way too long as usual, so I might make the buzzer in a separate video, but basically the buzzer, you just take this out and put a buzzer in its place. And actually, you know what, it's not even really worth a whole nother video, so let's just quickly have a look at that. Where are we? A box of stuff. Here we go. You can get these probably quite easily on eBay or whatever as well, and this is just a piezo buzzer, I think, or I'm not even really sure what they're called, but you just put one side into positive, one side into negative, and they usually can handle up to quite high voltages, typically about 25, 35 volts, something like that. There's a little hole in there at the top, and to run this from Arduino, you basically just connect this to a digital pin, and then set that digital pin high and low very quickly, and that will shake the diaphragm inside there, and it'll make a horrible noise. And you can experiment with how fast you turn it off and on to make different pitches of sound. And yeah, you can actually do that directly from the Arduino here. In fact, since I've come this far explaining it, let me just connect this one up, and we'll have a look at, or have a listen to what results we can get from this one. Okay, I've connected this up now, and it's pretty simple. I just have the negative side of this going to ground, and the positive side is going to pin 4. And the positive connection on these will typically be longer, so the little pin there will be a little bit longer for the positive side. And I've just uploaded this sketch here, so this is the Arduino 101, 1 second on, 1 second off for pin 4, and you may be able to hear a little bit of a noise coming from that. Let's reduce the time that it's turned off and on by a factor of 10. Sounds like an alarm clock, doesn't it? And you can also get different effects and quite horrible grating sounds by changing things so that it's on for less time than it's off, and so on. So if we make it on for 50 milliseconds and then off for 100 milliseconds. Now it sounds like a watch, but anyway, you can play around with that. Now the point I'm trying to make here is that this does actually work from the weak-ass 5 volts, or it may even work from the 3.3 volt Arduino, but you're not going to hear this from even like a few meters away, especially outside when the wind's blowing, when it's fallen into some long grass. I actually tried it and I thought, because actually if I take this little sticker off, we might get a bit more noise coming out too. Here we go. So I tried it inside here at my desk, and I thought, oh, that's loud enough. But then I took it outside, and no, not loud enough at all. So that's why we need to also do the same kind of thing that we have here with our power transistor. And when you power this little guy from the main battery through the transistor, that's going to be loud enough. So take it from me, after having learned the hard way that 5 volts or 3 volts on here is just not going to be good enough. In fact, here's a little bit of video that I took actually that time when I learnt the hard way. Can't even walk through here. Getting nowhere. Yeah, I made it about 2 meters. And of course, yes, you may be thinking, why is this guy using delay here when he's just spent the whole video telling us not to use it? Yes, I should mention that. The reason I'm okay with using delay here is because this function is something that happens when you're not flying. So the idea is you crash somewhere and you're trying to find your quadcopter, so it's not flying anyway. So you would flip a switch on your transmitter to enable this mode, so you don't care really too much if you're receiving your radio signal at full speed or not. So in this case I'm okay with using delay. Okay, so I installed everything and it's just running the blink sketch. Well, slightly modified blink sketch. It's doing 1 second on and then it's doing a quick 2 flashes. And I'm just running it like this for a while just to check if my transistor under here is getting warm, but it seems to be fine. So next thing to do is instead of just the blink sketch, obviously we want to have the receiver, radio receiver, and switch this from the transmitter. And that took all of about 30 seconds because it's just a few lines of code to add to the receiver sketch. Now of course I haven't flown it to check 100% that it's okay, but I can't see any potential issues with this just from the code that I've added. So just have a quick look at what the code I added was. In the setup function of the receiver, you just need to say that pin 4, in my case, whatever pin you're using is going to be an output. And then in the loop, I added these lines here just to check if the first bit of the switch's bit flag was set or not, which is the switch that I have here. And if it's set, we write a high to pin 4, otherwise we write a low. Now I don't think this is going to take very much time at all, so I don't see any problems, potential problems with flying. So that's it for the switches. I don't think I'll add the single white LED in this video because it'll take a bit of time. But hopefully I can add a little bit of video of flying this at night just to see what it looks like. And one thing I might just quickly check is using some PWM on the dial for these lights to see if we can get them dimming from the dial over the radio link. Okay, so now I've connected my signal to pin 5, and I added just a couple of lines. So I added pin mode 5 being output in the setup function, and I changed this to 5, and now we can see that we get a proper dimming behavior. Actually dims quite smoothly. So I guess these powerful LEDs have a bit more, they seem to dim nicer than the tiny little LED does. Although they do drop off quite suddenly at the end. But this should be quite nice to use with the single really bright 3-watt white LED underneath the quadcopter. Should make quite a nice effect. Anyway, so I'll set the other LED up, and I'll perhaps make a video of flying this at night. And yeah, so that's there we go, another huge long video. Thank you if you're still watching, and see you next time. Well, I thought I was going to stop just there, but I added the new, the other light on the bottom there, just on a piece of aluminium as a heatsink. There we go. And I made that so that it uses the analog, the dial to turn on like this. And that works okay, except for when you go to fly it. I found that it seems to be the amount of power that it draws is causing problems for something in the the radio connection, I think. Basically all the controls are delayed by about 1 second or so, and it's just impossible to fly. But what's interesting is it's not related to the analog write or the timer that we're using. It seems simply related to the amount of power. So if I put it on low power like this, it's actually still kind of flyable. It's not too bad. And when I start to raise it up, it gets worse and worse until when it's on full power like that, it just can't be flown at all. And I've tried changing the pins, so I switched over so that the pins were the other way around, and I tried using the analog write for these LEDs instead, and these ones work fine in any case. So it really just does seem to be down to the amount of power that's being sucked out of the battery in this LED's full power case. So unfortunately I won't be flying with this LED tonight, but I'll just stick to using these ones. But that should still be fun. So yeah, I'm not really sure what the problem is there, I'm afraid, but just thought I should warn you in case you want to try this and think that it might work when it probably might not. Okay, we're down here by the river. There's nobody around. This is quite nice, so I don't have to worry about crashing into anyone. And so I've come over by the baseball fields again, where there's no trees and no long grass, so if I dump it somewhere I'm not going to have too much trouble finding it. And as you can see, it's a beautiful clear night, and it's a full moon, so I didn't actually need any lights to put my props on and hook up the battery and everything. I could do everything by the light of the moon. How romantic. So anyway, this is what it looks like there. And I will try the white light a little bit. That's on full there. But I also added a switch for this, so I can just... Whoops, holy shit. I also added a switch, so I can just quickly switch it off and on like that. So it's using the dial and one of the switches together. So I can switch it off independently. Now if I change the dial to full, I can just quickly try it at full like that to you know, just in case it starts to behave erratically, I can quickly turn it off again. Anyway, I'll put the dial down to the smallest level. Man, it's freezing cold out here, so I'm doing everything with gloves. So this is the first time I've tried flying with gloves, and I can't feel the switches and the dials very well, so not sure how it's going to go, but let's give it a try. Come over here. Okay, as I suspected, I lose control somewhat when I turn the white LED on, and when the white LED is off, everything is perfect. Feels really good. And I've got to say, this is actually quite a lot of fun to fly, because in some respects I can actually see it better like this than I can during the day, and I can see clearly which way it's facing and everything. So yeah, I'm just going to finish up the video here, but I have 2 more batteries and about half of this battery left, and I'm going to fly them all. See ya.